So we're going to look at question 6 now from the physics tutorial book, unit 2. An object rolls down an inclined plane with initial velocity of 0.8 meters per second. It reaches a speed of 1.6 meters per second in 6 seconds. Calculate the acceleration of the object. B. Calculate the distance covered by the object during the first 10 seconds. Okay, so what we're going to do is we're going to assume constant acceleration. Notice how it's quoted both the initial velocity and the final velocity to 3 significant figures, and the time to 3 significant figures. So we're going to be giving our answers to 3 significant figures. Okay, so I'm going to call up GeoGebra, and I'm going to type in U for our initial velocity. So our initial velocity was 0.8 meters per second. Then I'm going to put in V for a V of 1.6 meters per second. Okay, and okay, so it's actually asking us to calculate the acceleration of the object. Okay, so our delta, so acceleration is delta V over delta time. So delta V is final minus initial, so that's 0.8, and our delta T is 6. So what we can do is we can come up here and we'll go A is equal to 0.8 divided by 6 seconds, and we'll press enter. Okay, so we've got our V, U, our V, and our A. Okay, so that's our answer of our acceleration of our object. It's accelerating at 0.133 meters per second. I'm happy with that because that's to 3 significant figures, because we don't count the 0 at the front. Now, part B, calculate the distance covered by the object during the first 10 seconds. Okay, so what I'm going to do is I'm going to type in S, up here, S brackets T. So displacement is a function of T. So from our third equation of motion, we go U times T, U times T. Notice how we've got a graph up here. And then we go plus a half. So a half is 0.5, half AT squared. So times A for acceleration, times T, and then squared. So I'll bring my little keyboard up here, squared, and then I hit enter. Okay, so notice how already it's given us our nice parabola. So we expected it to be a parabola. Now the question, going back to the question says calculate the distance covered by the object during the first 10 seconds. So what I'm going to do is I'm just going to come back here, S brackets 10. So by putting S brackets 10, that's saying the displacement at T is equal to 10, and it has given me this number here of 14.67. Okay, so we actually are working to 3 significant figures, so this would become 14.7. So that's how many meters will be covered in the first 10 seconds, and we can, if we were to zoom out on our graph, zoom, 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 and what I might do is I'll just grab this and move this along. So here's our 10 seconds. Okay, so 10 seconds would bring us up to here, and that's well, it's not quite 15, is it? So we can roughly say it's 14.7, which is what this gives us here.